In this video, we are going to be talking about binomial experiments. So first, let's look at some vocabulary. A binomial distribution is a type of probability distribution that shows the probabilities of the outcomes in a binomial experiment. And a binomial experiment meets the following conditions. First, there are n independent trials, and each trial has only two possible outcomes, success and failure. And the probability of success is the same for each trial. And so we have that the probability of success, that's always going to equal to p, and the probability of failure is then going to equal 1 minus p. So the probability for success is 0.7, then the probability of failure would be 1 minus 0.7, which is 0.3. And then we have this formula to find the probability of k successes. So the probability of exactly k successes in n trials is nck, so our combination formula there, p raised to the k power times 1 minus p raised to the n minus k power. So let's go through a couple of examples of using a binomial distribution. So we're going to calculate the probability of flipping a coin 30 times and getting the given number of heads. So for this, we're going to be using this formula right here. So I see in this formula, I need to know what my n is, I need to know what my k is, and I know what my p is. Well, n is the total number of trials, and I see I am flipping the coin 30 times. So n is 30. K is my number of successes. For number of 1, I'm looking to get 4 heads. So I'm looking at k is equal to 4. And then I figure out, okay, what's the probability of success? What's the probability that I flip a head? Well, if I'm looking at a coin, that is probability of flipping a head is just 50% chance, so it's going to be 0.5. And so that means that 1 minus p, it's going to be 1 minus 0.5, which is also 0.5. Now I can plug all that into my formula. So I have the probability of 4 heads is equal to 30 C 4, p, which is 0.5, raised to the k, which is 4, and then 1 minus p, which is 0.5, raised to the n minus k, so 30 minus 4. And if I do 30 minus 4, I get 26. And now I can go ahead and plug this all into Desmos. So going over to Desmos, I can do this combination in here. If I go to functions and scroll all the way down, I'm going to hit NCR. And so I'm going to do 30, comma 4, close that parentheses, times 0.5 raised to the 4th. I'm going to hit this A, B button and click 4, right arrow, and then times 0.5 raised to the 26 power. And so I get this very long decimal, so it looks like this is going to be a very low chance. So the answer here is going to be 0.00003. Okay, let's look at another one. So here, now my number of successes is 10. So I have n is equal to 30 still. Now I'm looking to see when I get 10 heads, p is still 0.5. 1 minus p is also still 0.5. So now find this probability. I have probability of 10 heads. It's going to equal to nck, so n is 30, ck, which is 10, times 0.5 raised to the k, which is 10, and then 0.5 raised to the n minus k, so 30 minus 10, which is 20. And so now I'm going to plug that in here. So I'm just going to delete and replace. So I'm going to replace that 4 with 10, replace this 4 with 10, and replace this 26 with 20. And I say this ends up being a higher percent chance. And so rounding this to 3 decimal places, I get that this is approximately 0.025.